Hello, today we are going to solve the problem of the day from LeetCode. In this case, this problem is giving us a calendar, a problem related to a calendar, and we have events that have a interval. The interval is open, half open, sorry, and we have it like closed at the beginning and then, close it at the beginning and then open at the end. We need to they will give us events with these intervals of beginning and end, and we need to check every time that we are inserting a new event if there is some overlapping with an already scheduled event, let's say, and we cannot allow double booking. For that reason, when we can book an event, we should answer true, but when we cannot, because there is some overlapping with an already scheduled event, then we should answer false. Okay, I am going to explain this problem in this whiteboard because it will be easier to explain graphically. We have two cases. Let's say we have the case 1, and we also have we have two cases. The idea of the problem will be logically sorting the events according to the start time, and we are going to check why now observing the cases. Let's assume that we have already defined the following events in our calendar. Sorry for the lines. Yeah, let's assume that this is a temporal line where the time increases in this direction, and these are the start times, and this is the end time, and also this is the start time and this is the end time. Let's assume that we have a new event that we want to insert. Let's assume that for this case, our new event is in a time range that is, let's say, before any other time range already placed on the let's say calendar. Let's assume that this is our event, and this is its start and this is its end. Then we know, okay, I already have the event sorted in the calendar, and then I have a new event. What will be the worst case or the edge condition that I need to check? Basically, I need to check if the calendar is already sorted, I only need to compare this end time of the new event and the first event already booked on the calendar. But if we saw that in the other way around, we assume that we made let's say a search in our calendar, and we asked for the lower bound, assuming that our calendar is sorted by start time, the lower bound property of our calendar for this new event end. New end. And if we have that this is equal to the beginning of the calendar, or let's say the first event, then we can say, okay, I can add the event, because also it's important to notice that two events can go in this way, because we remember that the end time is open and the start time is closed. Yeah, in that way it is possible to have one event finishing and then the other event starting at the same time. Okay, this is the case 1, but then let's assume again that for the case 2 we already have our events scheduled in our calendar, and our calendar is sorted by start, timestamp. But now in this case too, we will have like two scenarios. Or to explain like more intuitively, because at the end is the same like scenario, but that can arise two possible answers. Let's say then that now we have a new event that could come here. And in this case, it is not possible to add this new event because it overlaps. And then let's assume that our new event comes here. Again, trying to reduce the idea of the lower bound. If this is the end and this is the start, what will be the more closest event that has begun before our new end? In this case is this one, right? And in this other case, again we have our start and our end. What is the closest event that that is scheduled in the past, let's say? In this case is this one, right? But what is the difference between those two cases? Let's use another color. Let's put this also S2 and A2. And this in this case is also S2 and A2. The difference between these two cases is that basically here we have that E2 is is less or equal than start, and here basically we have that E E2 is higher than start. Sorry for the for the letter, but basically we notice that these conditions are the opposite. That means that we only need to check this condition, and if this condition is true, then we know that we can insert a new event. But if this other condition, like that E2 is higher than start, then we know that it's not possible to schedule the event. Okay, I hope that the idea was more or less clear. Then we're going to pass to the coding part. Okay, first we're going to maintain our list sorted of events using the start, using a map, because we know that the map is already sorted. And let's call it calendar. Then we're going to start adding events with the book method. But before adding a new event, we need to know if it is possible to add. Let's call it possible, and let's initialize as false. But then at the end, if it's possible to book, then we are going to add this to the calendar with the start and end. The map automatically will ensure that we have the event sorted by start date. Then we need to check the case 1 and case 2. But both cases are based on basically lower bound. For the reason we need to do the lower bound. Let's call it because at the end it's an iterator. Calendar lower bound. Remember that we did the lower bound with the end. Then For the case 1, if the iterator is equal to the beginning of the calendar, then we know that we can insert the event because it's possible to add it. Then for the second case, oh, I forgot to mention something also important, is that in this case, we are doing like the lower bound condition will not return this event because this event has its start date before. It will return the next one. And also the same here. For that reason, we need to subtract or go to the previous iterator. Okay, then we already know that we can go back because this is not the first element of the map. And then we need to check the condition. For that, we need to have the, let's say, last event end time, last before event, last event before new, let's call it, end time, or yeah, end. And this will be like, in order to access the in a map, usually you can, like, by the iterator give you like the key and the value, and if you want to have the value, then you need to do this because this is a pair. Sorry, this is the key and this is the value. And then if last event before new end, or let's rename this, end of last event before new, in this way it is more understandable. If the end of the last event before new is less than the start, then we can insert the new event. Otherwise, we have our possible variable initialized as false. We can also convert this into this way to not. Yeah, this is the same. And yeah, this will be all the problem. Let's test this. Oh, we have some error. Ah, yeah, we're forgetting to return the boolean to check if it's possible or not. Okay, for this case we have correct, null, true, false, true. This means let's copy the solution and send it. Oh, yeah, sorry, I forgot to copy the first line. Okay, then let's submit it. Okay, I hope that the explanation was clear. If not, let me know in the comments. Thank you.